Okay, in this video, we're going to look at simple machines. Simple machines. So, what is a machine in physics? A machine is a device which allows a force applied at one point to overcome a resisting force at another point or at another end. A machine is a device which allows a force applied at one point. The force is applied at one point, and then that force is used to overcome a resisting force at another end or at another point. So, for example, a wheelbarrow is a machine, right? So, it is a device that allows a force applied at one point. And so, the man applies a force at this angle, right? He applies a force into the wheelbarrow through this angle. And then that force is used to overcome a resisting force. That resisting force is the load that is trying to resist the force that you're applying into the wheelbarrow. So a machine is a device which allows a force applied at one point to overcome a resisting force at another point or at another end. In a layman's language, a machine can be defined as a device which makes our work easier and faster. So it's a simple device that makes our work easier and faster. So these are types of machines that we have. These are the various categories of machines that we have. We have the lever, pulleys, inclined plane, hydraulic press, screw, wedge, gear wheel, and the wheel and axle. So these are the 8 basic types of machine that we have. Lever, pulleys, inclined plane, hydraulic press, screw, wedge, gear wheel, and axle. These are the 8 basic types of machine that we have, and we're going to look at them later in another video. So the wheelbarrow that we have here is an example of a lever, is an example of a second class lever, right? So the main thing that you should know here, know the types of machines that we have. They are basically 8, and they are lever, pulley, inclined plane, hydraulic press, screw, wedge, gear wheel, and axle. And know what a machine is. It is a device which allows a force applied at one point to overcome a resistive force at another end. So here we're going to look at the terms used in simple machines. Basically, there are 3 terms that are used in simple machines. We have the mechanical advantage, velocity ratio, and efficiency. The mechanical advantage, velocity ratio, and efficiency. So we're going to take the first one, which is the mechanical advantage. So what is mechanical advantage? It is the ratio of the resisting force to the applied force in a machine. The ratio of the resisting force. The resisting force, like I said, is the load to the applied force. The applied force is the effort. So it is the ratio of the resisting force to the applied force in a machine. It is also known as the force ratio. Mechanical advantage is also known as force ratio. So mechanical advantage MA is equal to load all over what? Effort. It is the ratio of the resisting force. The resisting force, like I said, is the load, and the applied force is what? The effort. So mechanical advantage is equal to load all over what? Effort. It is the ratio of the resisting force to the applied force in a machine. So let's look at this question. An effort of 50 Newton. An effort of 50 Newton. What does that tell you? That the effort is what? The effort is what? 50 Newton. So an effort of 50 Newton is applied to a load of 100 Newton. What does that tell you? That the load is what? 100 Newton. With the aid of a simple machine, calculate the mechanical advantage. I read again. An effort of 50 Newton is applied to lift a load of 100 Newton with the aid of a simple machine, full stop. Calculate the mechanical advantage. So mechanical advantage, like we said, is the ratio of the resisting force, which is the load, to the applied force. So mechanical advantage is load all over what? All over effort, right? So this is equal to, the load is 100 Newton over the effort is what? 50 Newton. So 100 divided by 50 will give us what? 2. So the mechanical advantage in this machine is equal to 2. That is the answer to this question, right? So let's look at the next term used in simple machine, and that is the velocity ratio. So velocity ratio is the ratio of the distance moved by the effort. It is the ratio of the distance moved by the effort to the distance moved by the load. So velocity ratio VR is equal to distance moved by the effort over distance moved by the load. Ratio is division, right? So velocity ratio is equal to distance moved by the effort over distance moved by the load. Velocity ratio can also be equal to effort over load, right? So let's take this question. If the effort moves 2 meters while the load moves 0.5 meters, what is the velocity ratio? If the effort moves 2 meters, so that means distance moved by the effort is what? 2 meters. So distance moved by the effort is equal to what? 2 meters. While the load moves 0.5 meters, that means the distance moved by the load is equal to what? 0.5 meters. What is the velocity ratio? So like we said, velocity ratio is the ratio of the distance moved by the effort to the distance moved by the load. So velocity ratio VR is equal to distance moved by effort over the distance moved by what? The load. So the distance moved by the effort is 2, so that will be equal to 2. That's the distance moved by the effort over the distance moved by the load is 0.5, so over 0.5. So 2 divided by 0.5 will give us 2 divided by 0.5 is equal to 4. So the velocity ratio is equal to 4. That is the answer to this question. It is very simple and straightforward. So the next term we're going to look at is efficiency. So what is efficiency? Efficiency is the ratio of useful work done by the machine to the ratio of work put into the machine. It is the ratio of useful work done by the machine. So of useful work done by the machine to the ratio of work put into the machine. Efficiency of a machine can also be defined as the ratio of the mechanical advantage to the velocity ratio of the machine. So the formula here is efficiency is equal to work done by the machine over work done on the machine. Work done on the machine is work put into the machine. Work that is put into the machine. Work done by the machine is the useful work that is done by the machine. So efficiency can also be equal to mechanical advantage over velocity ratio from the second definition, that it is the ratio of mechanical advantage to the velocity ratio of a machine. So efficiency is equal to mechanical advantage over velocity ratio times 100 all over 1. Efficiency is equal to work done by the machine over work done on the machine or work put into the machine times 100 all over 1. Efficiency is usually expressed in percentage, right? Okay, so let's look at this particular question. A man uses 300 joules of work to lift a box. A man uses 300 joules of work to lift a box. What does that tell you? That the work put into the machine is what? 300 joules. A man uses 300 joules of work to lift a box. He uses, that means the work done in the machine, the work that is put into the machine is what? 300 joules. So work done in the machine is equal to what? 300 joules. The useful work done is 240. The useful work done, what does that tell you? That the work done by the machine is what? 240 joules. So work done by the machine is equal to 240 joules. Then the question is find the efficiency. So efficiency of a machine is the ratio of work done by the machine, useful work done by the machine. So that is equal to, efficiency is equal to work done by the machine. So is work done, WD, work done by the machine, over work done in the machine, the work that you put into the machine, times 100 over 1. So the work done by the machine is 240 joules. That's the useful work done by the machine. So efficiency is equal to work done by the machine. The work done by the machine is what? 240 joules over the work done in the machine. The work that is put into the machine is what? 300 joules times 100 over 1. Right? So this 0 will cancel out this 0. This 0 will cancel out this 0. 3 here is 1. 3 into 24 is 8. So 8 times 10 is equal to 80. So the efficiency is equal to 80%. Right? Efficiency of the machine is equal to what? 80%. Here is another question. A machine has a mechanical advantage of 4 and a velocity ratio of 5. What is its efficiency? So here we have the mechanical advantage to be equal to 4 and the velocity ratio to be equal to 5. What is the efficiency? Efficiency of a machine is equal to mechanical advantage over velocity ratio times 100 over 1. So the mechanical advantage of the machine is 4 over the velocity ratio is what? Is 5 times 100 over 1. So 5 here is 1. 5 into 100 is 20. So 4 times 20 is equal to what? 80%. So the efficiency of this machine is 80%. So we're going to look at this question, and this will be the last question that we're going to look at in this video. So the question is, an effort of 20 Newton is applied to lift a load of 120 Newton. An effort of 20 Newton. So that tells you that the effort here is 20 Newton. Is applied to lift a load of 120 Newton. So the load is what? 120 Newton with the aid of a machine. So an effort of 20 Newton is applied to lift a load of 120 Newton with the aid of a machine. The distance covered by the effort and the load are 50 meters and 200 meters respectively. So the distance covered by the effort, distance covered by the effort is equal to what? 50 meters. And the distance covered by the load is equal to what? 200 meters. So distance covered by the load is equal to 200 meters. The distance covered by the effort and the load are 50 meters and 20 meters. So that's what we have here. Distance covered by the effort is 50 meters. Distance covered by the load is 200 meters. Then the question is calculate the velocity ratio of the machine. So what is the velocity ratio of the machine? Velocity ratio of the machine is equal to distance moved by the effort over distance moved by the load, right? So velocity ratio is equal to distance moved by effort over the distance moved by what? The load. So we looked at it here that the velocity ratio of the machine is the ratio of the distance moved by the effort to the distance moved by the load. So velocity ratio is equal to distance moved by the effort over distance moved by what? The load. So we are not using this effort all over load because we have this. In a situation where we have the distance moved by the effort and the distance moved by the load, we don't use velocity ratio to be equal to effort all over load. I hope you get that. Yes. Back to our calculation. So velocity ratio is equal to distance moved by the effort over distance moved by the load. So the distance moved by the effort is 50 meters. So that is equal to 50 over the distance moved by the load is 200 meters. So 0 cancel at 0. 5 divided by 20 will give us 5 divided by 20 is equal to 0.25. So my velocity ratio is equal to what? 0.25. So I have answered the number 1 question, and this is our answer. Then the next question, question 2, is to calculate the efficiency of the machine. Calculate the efficiency of the machine. So efficiency from the parameters we are given here is equal to mechanical advantage over velocity ratio times 100 over 1. So we have our velocity ratio already to be 0.25, but we don't have our mechanical advantage, right? So let's solve here. Mechanical advantage is equal to load over effort. Mechanical advantage is the ratio of the load to the effort, or mechanical advantage is the ratio of the resisting force to the applied force, right? So that's load all over effort. So that is equal to, my load is 120 over my effort is what? 20. So 0 cancel at 0. 12 here, 2 here is 6, 2 here is 1. So 6 divided by 1 is 6. So my mechanical advantage is equal to 6. So now I have my mechanical advantage, I have my velocity ratio, I can now look for the efficiency, right? So the efficiency of the machine will be equal to mechanical advantage over velocity ratio times 100 over 1. So the mechanical advantage is 6 from what we've gotten here over the velocity ratio is 0.25 times 100 over 1, right? So 6 times 100 is equal to 600 over 0.25, because 0.25 times 1 is 0.25. So 600 divided by 0.25, that will be 600 divided by 0.25, that is equal to 2400%. Well, this is not very realistic. This is not realistic at all. This is not realistic. So the last thing I would want you to know here is, why is the efficiency of a machine less than 100%? If you calculate the efficiency of most machines, it is usually less than 100%, or it is less than 1. It's less than 100% or less than 1. And the reason is because some of the energy put into the machine is always lost, right? Some of the energy input is always lost, usually in the form of friction. So, for instance, the total work done you put into this machine is not equal to the work done that is done by the machine. So some of the energy, some of the work that you put into the machine, they are lost through friction. So the reason why the efficiency of a machine is less than 100% is because some of the energy input is always lost, usually in the form of friction. Some are used to overcome friction, which is the force that opposes motion between two surfaces. Then some are used to overcome, some are lost in the form of heat, some are lost in the form of sound, some are lost in the form of vibration, and some are lost in the form of electrical resistance. So the efficiency of a machine is never 100% or cannot be one, because some of the energy inbuilt is always lost in the form of friction, heat, sound, vibration, or what electrical resistance. So this is a very important question. So that is why I said that this calculation here is not really realistic, right? Because the efficiency of a machine cannot and will not be up to this 2400%, right? So this question is not realistic.